Okay, so remember that if I have a group of three objects, A, B, and C, a combination of these three objects taken two at a time is just a subgroup of size 2. So what are the combinations of three objects, A, B, C, taken two at a time? Well, it's A, B, B, C, and C, A, right? So the number of combinations of three objects taken two at a time is 3. Okay. Okay, it's 3, and now one thing I want to do here is that I want to count that number 3 that we obtained in a different way. Okay, so suppose that I didn't write down all possible combinations of three objects A, B, C taken two at a time. So we explicitly wrote it down here, right? Let's say you didn't do it, you're just going to count how many are there. So how would you be able to do that? Is my question clear to you? I don't want to list out the subgroups of size 2. Instead of that, I just want to count the number of subgroups of size 2. Right? The number of subgroups of size 2. How can I count that? So let's try to do that. The trick is we are going to count the number of permutations of three objects taken two at a time. Remember the number of permutations of two objects taken two at a time? We are going to count that number in two ways. One is we already know the answer. The other way will be in terms of the number of combinations. Okay? So let's let X be the number of combinations of three objects taken two at a time. Okay. Now this is going to be important. You have to understand permutations and combinations. Otherwise, in chapter 3, when we start doing probability questions, you're gonna have a hard time. Okay. So counting problems are important when we try to do probability problems. So X is the number of combinations here. Then I want to find X, right? That's the goal. So here's what I want to ask you first. What is the number of permutations of three objects taken two at a time? What was that number we counted? We denoted that number by what? P. 3, 2, right? You guys are reading your notes when you go back home? Okay, you better do that and remember these things, right? Okay, so what was the formula for this? What is P32? What is P and K? Right? What was the formula? The top number goes in the numerator, 3 factorial. In the denominator, what do you have? Yeah, so that's 3 minus 2 factorial, right? So that's we know already that number. But now I want to count this I want to count the number of permutations of 3 objects taken 2 at a time in a little bit differently. How? Remember, I have X subgroups of size 2, right? I have X subgroups of size 2. Now, if I have a subgroup where I write AB, right? And if I have another subgroup where I write BA, are they different? Are they different? If I take a group of 2 elements A and B, and if I take another group of elements B and A, are they different? No, they are the same group, right? When you are talking about a group of 2 elements, order is not important, right? If I'm picking a subgroup of size 2 from this class, right? If I'm picking 2 students from this class, it doesn't matter in which order I'm picking them, right? So here, when I'm talking about combinations, right, where order is not important. Order is important for permutations, right? So if I have X subgroups of size 2, now for each subgroups, right, for each subgroup of size 2, how many ways, how many arrangements are there of the 2 objects in the group? If you pick a subgroup of size 2, you have 2 elements. How many arrangements do you have for the 2 elements? 2 factorial, right? Does everybody agree with that? You guys agree with that? So remember, I have X number of subgroups of size 2. For each one, the elements of each one can be permuted in 2 factorial ways. The elements of each subgroup can be permuted in 2 factorial ways. So it's because I have X of them, so there is a total of X times 2 factorial. There is a total of X times 2 factorial ways, right? We can permute 2 objects taken from 3 objects. Is that making sense? So think about how you're going to list out the permutations, right? So you have 3 objects, you are taking the permutations of 2 at a time, right? So from 3 objects, what are you doing? You pick 2 of them, right? And then you can write them as AB and BA, right? Pick another pair, BC and CB, right? Am I making sense? So all I'm saying is that pick a subgroup of size 2 and look at how many permutations you have. Pick another subgroup of size 2, how many permutations you have of the 2 elements. Pick another subgroup of size 2, right? And then look at how many permutations you have of the 2 elements, right? And keep doing that. That's the number X times 2 factorial, right? And that's the same as the number of permutations of 2 taken, number of permutations of 3 taken 2 at a time, right? Is that making sense? Well, I have an equation and I can solve for X now, right? What is X? What is X now? Notice that X is 3 factorial divided by 3 minus 2 factorial multiplied by 2 factorial, right? I have to divide by 2 factorial to solve for X. And what is that number? What's that? Does everybody see that that's 3? Because 3 factorial is 3 times 2 factorial, right? And everything cancels out here except that you're left with 3. You agree with that? You can simplify 3 factorial over 2 factorial times 1 factorial, right? Does that simplify to 3? Can everybody do that arithmetic? Did you check that you get 3? So that's exactly what we got by explicitly writing down the subgroups of size 2, right? We had 3 of them. A, B, B, C, C, A, right? Is everybody okay with that? All right.